Hello, EFR 516 students. We're working on online example 01, and here we're working on the example, not the actual assignment. So again, the example's showing us how to do things, and then we'll watch the example, and we'll do the example, and then we'll do the actual assignment. So in this video, we're going to be doing problems 2 through 5. 2, 3, 4, and 5. And these are four parametric problems, meaning they assume the normal distribution in there. So we'll look at the first one. It says parametric between samples and two groups. So there's two groups here. There's group 1 and 2. For example, there's male and there's female, and they're dependent variable and independent variable. So we're going to run a independent samples t-test between these two, where it's going to be non-directional. So now when I open my SPSS data, right, the file was example review of basic test SPSS data, and and so again, this is for the example. Okay, so our data is already in SPSS. So here's our first one, our first variable coming from this problem. So problem number 2. So to run a paired t-test between the dependent variable and the independent variable, I'm going to come up to Analyze, Compare Means, Independent Sample t-test. Analyze, Compare Means, Independent Samples t-test. Okay, the dependent sample goes in test variable. The independent sample, which is our grouping variable, goes here. Now once I bring it over, I need to click on it here. Okay, and then say define groups. Well, I know they're labeled 1 and 2, my groups are. For example, male and female, or control and treatment. So I'm going to label them here 1 and 2. They don't have to be labeled 1 and 2. I'll say continue. And for the purposes of this example, we're just going to say OK. Okay, we get our results here. Now, it's a T with 18 degrees of freedom. Its value of the T is 0.241. And is it statistically significant or not? Here's the sig two-tailed. Is this less than 0.05? Okay, and it's not, so it's greater than 0.05. So for example, I can grab this table, and I'm just going to copy it over into my assignment. So I can paste it right here. And again, what we see, if we go up to the beginning of the assignment, I'm asking you to put the final product up here. So here's for our first assignment. So I'm just going to grab that. I'm going to pull that down here to write this in. So from the results. So it's a T with how many degrees of freedom? Here's the degrees of freedom, 18. Its value right here is 0, 0.241, and is sig here, the sig two-tailed, because it's two-tailed test. This is the actual p-value. It's 0.812. So is that greater than or less than 0.05? Well, it's greater than. So I'll put greater than. It's greater than 0.05. Now in APA, if the number can be bigger than 1 or minus 1, gets a 0 in front of it. So the actual t, which can be bigger than 0 or bigger than 1, right here, you notice there's a 0 in front of it. But the p-value cannot be greater than 1, so it doesn't get a value in it. So that's our answer here for the first one. So I'll just take this and I'll bring it back up to the assignment. And for the answer, I'll just paste this right over. Okay, and that's the answer for the first one, meaning we don't find evidence of statistical significance for our first test we've done here, which was the independent sample t-test. Okay, we'll come down to the next problem, which is number 3. And this problem says, run the following analysis, write up your results in APA Centex. So this is the parametric between samples and more than two groups. So we're going to use a one-way ANOVA for more than two groups. So we just have group 1, group 2, and group 3. So again, this is problem number 3 as we see here, and that's already over in our data set in our SPSS. So here's problem number 3, these two values. So I'm going to go Analyze, General Linear Model, Univariate. Analyze, General Linear Model, Univariate. Okay, so we're working with number 3. The dependent variable for 3 is right here. The independent variable for 3 is right here. We'll put it under fixed factors. We won't do anything else for now. We'll just say OK. And here's our ANOVA table. Well, I'll bring this right over to the assignment. Just copying it. Okay, so I'll paste it right into the assignment. Okay, so we need to fill out our APA for this. Now, our independent variable line, this is the line we're interested right here in our ANOVA table. So it's an F, okay? Its degrees of freedom are numerator denominator. An F has 2 degrees of freedom. So the degrees of freedom on our line was 2, comma, the degrees of freedom for the air was 17. And again, this is review from 515. The value of that F was right here, 0.556. So because it can be bigger than 1, it'll get a 0, 0.556. And then is the P greater than or less than 0.05? And we see right here our P is 0.584. So it's greater than 0.05. So that means it's not statistically significant. Under the null, we have no evidence that these different groups, which are 3 of them, are coming from different populations. So I'm going to grab that answer, and I'm going to just run it up to the top. And I'm going to paste it right in here under the assignment. So this was number 3. Okay, so now we're going to do number 4. So I'll come down and look at number 4. So it says run the following analysis, write up your results using Centex. So it's a parametric. It's a within samples, 2 groups or times. So it's a paired test. So this is the paired test. For example, if I have time 1, I take a test, and then at a later date I take time 2, which is another test. So this is paired example, or they're twins, or etc., etc. So we have time 1 and time 2. So it's problem number 4. So I'll go over to the SPSS. So here's my data, number 4, time 1, time 2. So I'll go Analyze, Compare Means, Paired. Okay, you see this here? Paired t-test. Click on that. So our pair, again, time 1, time 2, bring time 1, time 2, and then I'll say OK. So here are my results. I'll grab this table right here. I'm going to grab it as a meta file. I should have, the thing is, I want to grab it so I can size it on my document when I bring it in, because otherwise it's just going to run off the page. Okay, so here it is. It's a T. So right here we see the T. It's 0.174, but we're going to point 0.74, 174, and it has 19 degrees of freedom. It's T with 19 degrees of freedom. And is the P greater than or less than 0.05? Now here again, at 0.863, it's greater than. So this is not statistically significant. So there's no evidence to suggest that time 1 mean is different than time 2 mean. So I'll go ahead and grab this. And I'll copy this up towards the top. I'll put it in the assignment. So this was number 4. Now we're going to do one more parametric one here before we get to the non-parametric tests. So number 5, come down and find number 5. So there's number 5. This is a one-way ANOVA. So it's parametric within samples. No, it's one-way repeated measure analysis. So parametric within samples, one-way repeated measure ANOVA. So to run this one, I'm going to look at my data. So I'm on problem number 5. I'll go to SPSS. So number 5 has time 1, time 2, and time 3. So just like the if I gave you one test and then at a later date a second test, well this time what if I gave you a third test? Okay, and that's a repeated measure one-way ANOVA. So we're going to go up to Analyze, General Linear Model, Repeated Measure. Analyze, General Linear Model, Repeated Measure. Okay, what we have is our factor is going to be time, because we're working with time 1, time 2, time 3. It's 3 levels, so I'll give myself a 3, and we're going to say add. Okay, then we need to define. We've added time, the time variable, and we're going to define that. So we're doing number 5. So here's our assignment. There's 1, 2, and 3, our 3 times. Now we can have a much more complicated model, and we're going to make some assumptions here, but again, this is just review. So then we'll go ahead and say OK. Okay, so now since this is repeated measure, we get a test of within subject's effect, and test of within subject contrast, and test of between subjects effects. So for us, we're just going to report the linear contrast. So right here, we're going to assume what's called sphericity. So if we didn't make some assumptions, we would pull some from up here from sphericity assumed, but we're just going to look at the linear contrast for this. Okay, and again, there's different things you can pull from this. Here are the between subjects, which we don't have any. Like if they're, for example, what if you had them for a control and a treatment group as well. So we're going to look at this table right here. I'm going to copy this over, copy it as a meta file so I can change its size and bring it back to the Word document. So here's our problem. Paste it in there. And so right here, our linear effect, it's an F, so its value is 19.612. 19.612. Its degrees of freedom, what's the degrees of freedom? It's 1, and the error is 19. So 1, and then 19. Numerator, denominator error. And what's our p-value? So we're going to come across here, and we see that it's 0.0000. So it's less than 0.05, meaning less than 0.05. And that means it's statistically significant, meaning the mean groups here for the different times are different. We can reject the null of no difference. So then we're going to come up and we're going to bring this up to our normal assignment up on top, and we're going to put it in that table. So for number 5, here it is right here. Okay, so this concludes a quick review of how to do our independent samples t-test, our dependent samples t-test, our one-way ANOVA, and our one-way ANOVA with repeated measure. And these are all parametric, meaning the distributions are defined by parameters, in this case the normal distribution, which is the mean and the variance. And for the next video, we're going to go ahead and do the non-parametric, where you're not making that assumption. So that concludes this video.